All right, so the last thing we're going to do is talk about acids and how to name acids. First of all, what is an acid? An acid is a compound that readily will give up a hydrogen ion when dissolved in water. Okay. So yeah, I mean, I know everybody's probably heard acids outside of a chemistry classroom. And so, you know, you kind of know that they're dangerous. You don't want to drink them or something like that. But what exactly is an acid? An acid is a compound that has a hydrogen that it's just ready to give up. Okay, so one classic example of a very strong acid is HCl. You kind of would be tempted to think about this as an ionic compound, and you can think of it like that, but it's a more complicated compound than that. It's an acid. It kind of falls into a category all on its own. We don't really treat it as an ionic or a covalent. We treat it as an acid. So because it has this hydrogen, and what's going to happen is if you put HCl in water, it's going to break up into its two components, the hydrogen ion and the chloride ion, right? But basically that HCl, it'll give up that hydrogen really readily, okay? This is corrosive because, so for example, if you spilled HCl on your hand, like what's the big deal? Well, basically it's going to go sticking hydrogens places that it shouldn't be. It really wants to get rid of that hydrogen. It's not just that like, oh, maybe it'll fall apart. No, it's going to actively start putting it places where it doesn't necessarily want to go, which is why it would end up damaging your tissue. So then we'll sort of see how we go about naming these by doing a few examples. So, you know, you might be tempted to kind of, if we just take this first example here, you might be tempted to give it a name such as hydrogen fluoride. That's how we would name it if it was an ionic compound, right? The first one, hydrogen, leave that as it is, and then fluoride. But again, we're going to treat this, you know, in its own separate category. So this becomes hydrofluoric acid. So instead of fluoride, you replace that IDE with an IC. So hydrofluoric acid, hydrochloric acid, not hydrogen chloride, hydrochloric, right? So hydrogen bromide, again, you just take the hydro, and then instead of bromide, you replace that with ic. Yeah. When we get to those, we also have acids that are made up of polyatomic ions. And then we have a little bit more of a complicated situation on our hands. But there's sort of a similar logic as to what we did before, right? For our simple ones, the ides turn into ics. For our polyatomic ions, if it ends with 8, that becomes ic. So this would have been a chlorate, would have been this, it wasn't one of the ones that we had to memorize, so you might not know this without looking at your cheat sheet. That's perfectly fine. You're still going to have to be able to turn your cheat sheet ions into acids if asked, right? So instead, ClO3 minus was a chlorate. If we're going to make it into an acid, it becomes chloric. So now HCl, and then you actually don't put the hydro in front of when it's a polyatomic ion acid. So this isn't hydrochloric acid, that's actually what the other one is. This is just chloric acid, right? So again, the 8 turns into an ic, and so that's why this is chloric acid. Remember, we had our polyatomic ions that were ending in 8, but then we also learned the rule. So if I gave you this and said this is chlorate, and 8 goes to ic, what if I gave you ClO2 minus? Remember what happens when we decrease in oxygen, but everything else stays the same. This would be chlorite ion. So I should put ion here too. And so in the same way that we have our 8s going to ics, we have ites going to us. So this is ite to us. So this would be chlorous acid. Okay. In terms of the acids, these are the ones that I think that you need to have memorized. Okay. All the halogens are there. So the hydrofluoric, hydrochloric, hydrobromic, hydroiodic, these all have halogen anions. And the other ones contain those same 4 polyatomic anions I told you have to have memorized, right? So the nitrate ion, remember 8s go to X. So this would be NO3 minus 1 is nitrate. This is nitric acid. Same thing with our CO3 2 minus was carbonate. So this would be carbonic acid. Sulfate, sulfuric acid. Phosphate, phosphoric acid. Okay. And then the last thing, right, that I'm going to ask is, let's actually do some other examples. These ones are all laid out in the lecture slides. Let's do some other examples because I want to drive home a point here. I could ask you H2SO4. And again, the logic would be, okay, I know that SO4 2 minus is sulfate and 8s go to ic. So so then this one would be sulfuric acid. But then what if I give you H2SO3? Remember, if SO4 is sulfate, SO4 2 minus, then SO3 2 minus is going to be sulfite. And just like 8s go to X, ites go to us, O-U-S. So this would be sulfurous acid. Okay, same logic. Let's, got some stuff I was hiding. All right, so same logic we can follow. If we were gonna do all right, so if I had, for example, we'll do HNO3, remember that NO3 minus was a nitrate, and 8s go to X. So this is nitric acid. But then what if I asked you for HNO2? Well, NO2 minus 1, again, we got to remember that rule. If I'm decreasing the number of oxygens, but everything else stays the same, this would be a nitrite ion. And then just like 8s go to X, ites go to us. So this would be nitrous acid. Okay. So these are little flowcharts. I don't know if they'll be helpful or not, but I did decide to leave them in there, little flowcharts for how you go about naming your compounds. I think it's broken down pretty well in the lecture slides. So if you are having trouble, I would watch one of those videos. I will say that for these types of things, practice, practice, practice. It's going to be very difficult when you do your first few examples, but the more that you do, the more you're going to get the hang of it. At the end of the day, it's just this set of rules that we have to apply to each given situation.